Okay, logarithms and exponentials are equal, or not equal to each other. They are related to each other. And what the first thing we're going to look at here is what exactly a logarithm is. So we see there in the first box, logarithmic form is log base b of a is equal to x. It's even got right below it exactly how you're supposed to read it. Okay, that's log base b of a equals x. That b is kind of like a subscript. Okay, it's kind of set below the line there with the log and the a. Where that comes from is exponential form. B to the x is equal to a. Okay, those say the same thing essentially. Okay, logarithmic form log base b of a equals x is the exact same thing as b to the x equals a. They're just in different forms because sometimes we're going to need it in one form to be able to evaluate it. Sometimes we're going to need it in the other form. It just depends on which part is the unknown. Okay, so let's start with the simple part, writing logarithmic equations in exponential form. This is super easy to do because I call it the swoop. You start with the base, you swoop around the equal sign, and you end back up in the logarithm. That's where the exponential form comes from. The base of the logarithm is the base of the exponential. You go around your equal sign and you end up back in the logarithm. So log base 3 of 9 equals 2 is the same thing as 3 squared is equal to 9 in exponential form, which we know is true, right? That's a true statement. 3 squared is equal to 9. Okay, number 2, same thing. We start with the base, we swoop around the equal sign, we end up back in the logarithm. So log base 6 of 216 is equal to 3 is the same as 6 cubed is equal to 216, which we know is a true statement. Okay, log base 7 of 1 is equal to 0 in exponential form. That is 7 to the 0 is equal to 1. We know that anything raised to the 0 power is 1. So we also need to learn that the log of 1 is always 0. The log of 1 is always 0. It doesn't matter what your base is, the log of 1 is always 0 because anything raised to the 0 power is 1. So anytime you see a log of 1, the answer is always 0. Okay, number 4, that would be 2 to the 4th is equal to 16. We know that already just based on our powers. Number 5, 4 to the negative 2nd is 1 over 16. Negative exponents moves it to the denominator. 4 squared is 16. And number 6, 9 to the 3 halves is equal to 27. Now, we don't really know that one by working it out in our heads, but you can type that into the calculator to confirm that. Okay, so pretty simple, right? Just going between log form to exponential form. Now, we can also go the other way. It's just, we have to think about it just a little bit more, in my opinion. I think it's a little bit harder to go from exponential form to log form, but it's still not hard, okay? So I mentioned before that the base of the logarithm and the base of the exponential are always the same. So that is log base 14. For number 7, it's log base 14. And really, it's like the other two numbers, just switch places. But if you're a little unsure about it, the easiest thing to do is after you write it in log form, just do your little swoop and make sure that that gives you the exponential form. 14 squared equals 196. So number 8, the base of the exponential is the same as the base of the logarithm. The other two numbers just simply switch places. So log base 3 of 81 is equal to 4 is the same as 3 to the 4th is equal to 81. Okay, number 9, 12 to the 1st equals 12. In log form, that would be log base 12 of 12 is equal to 1. That's something else we need to kind of learn. When the base of the logarithm and the number inside the logarithm are the same, it's 1, because that number raised to the first power gives you that number back. Number 10, log base 36 of 6 is equal to 1/2. Check it. 36 to the 1/2 equals 6. Number 11, log base 2 of 1 over 8 is equal to negative 3. Again, you can check it real quick. 2 to the negative third equals 1/8. Log base 8 of 16 is equal to 4 over 3. 8 to the 4 thirds equals 16.